What does our future hold? Everything has its wonders, even darkness and silence. What does the future look like? How will the universe meet its end? We may never be truly certain. But science has begun to paint a stunning picture of how the future might unfold. Let's take a journey to the end of time. We will travel through time exponentially. This vision of the future will surely evolve as we probe for more clues. But one thing is clear, the universe has only just begun. What we do now and in the next few years will profoundly affect the next few thousand years. The only conditions modern humans have ever known so far are changing and changing fast. Nothing stays the same on this planet. Everything changes. The Earth is going into one of these jumps, and you don't know what is going to be on the other side of those jumps. The Earth is always jumping. Year 2700, Earth's magnetic field flips. Year 3580, Comet Hale-Bopp returns. 5,500 years, drastic sea level rise. 6,877 years, 30-meter asteroid impact. 12,000 years, Antares goes supernova. 15,000 years, Sahara becomes tropical. 21,000 years, constellations begin to wander. 37,500 years, Voyager 1 passes nearby star. 60,000 years, interglacial period ends. 99,000 years, supervolcano erupts. 290,000 years, new Hawaiian island appears. 410,000 years, new island chains. 1 million years, Apollo footprints fade. 1,500,000 years, Betelgeuse goes supernova. 2,500,000 years, stone monuments erode. 8,500,000 years, deadly gamma ray burst. 12,500,000 years, Mars moon becomes a ring. 25 million years, Saturn's rings vanish. 40 million years, Antarctica melts. 68,850,000 years, major asteroid impact. 150 million years, new supercontinent. 400 million years, sun increases luminosity. 590 million years, photosynthesis ceases. 800 million years, all plant life dies. 1,200,000,000 years, oceans evaporate. 2,500,000,000 years, all life dies. Nothing stands still. Everything is in motion, spiraling forward as fuel runs low. The sun won't just quietly dim and disappear into the void. Instead, it will undergo a dramatic transformation. Its core will collapse under immense pressure, unleashing a burst of heat that will force its outer layers to swell and stretch across space. In this final, fiery act, the sun will die. But even in death, it lingers, a ghost of its former self, slowly losing its remaining warmth in the icy abyss of deep space. This fate isn't unique. Every star, no matter how grand, will meet this inevitable end. One day they will all flicker out, leaving the universe cloaked in perpetual darkness. Eventually, all stars will exhaust their fuel, causing the universe's temperature to plummet. One by one, the lights of the night sky will blink out, with no new stars being born to take their place. The universe will meet its end, not with a fiery explosion, but with a quiet, whimpering fade into darkness and cold. With nothing left to burn, only the faint glow of white dwarfs will remain, dimly lit remnants of stars whose feeble radiance comes from the last vestiges of their once raging cores. From where Earth is now, such a star would shine no brighter than the full moon on a clear night. These pale orbs will be the only beacons in an empty, dark void, scattered with the lifeless husks of dead stars and black holes. In a way, it will be a ghostly universe, inhabited by these celestial corpses, zombie stars that will linger on, guiding us into a bleak future. Eventually, even these will cool to become black dwarfs, the final, silent fate of those last stars. These white dwarfs, having grown so cold, will emit almost no heat or light. They will be dense, decaying balls of degenerate matter, little more than the ashes of stars, crushed to the point that a black dwarf will be 1,000,000 times denser than our sun. Reaching this state takes so long that, as far as we know, no black dwarfs yet exist in the universe. But if this slow, fading end sounds bleak, consider this. Our perception of time is tied to the energy available to us now. It's possible to imagine living, conscious systems with a much different pace of existence, stretching far beyond what we can currently comprehend. In such a future, life may find a way to adapt and persist, long after our familiar universe has gone dark. White dwarfs that have become so cold that they barely emit any more heat or light. Black dwarfs are dark, dense, decaying balls of degenerate matter. Little more than the ashes of stars, their constituent atoms are so severely crushed that black dwarfs are 1,000,000 times denser than our sun. Stars take so long to reach this point, we believe there are currently no black dwarfs in the universe. Any matter that fails to escape its galaxy is sucked into a supermassive black hole at the center. Long dormant black holes flare up in a blaze of glory. The rotational energy of black holes becomes the last reliable source of power for any exotic future civilizations. We have a pace of life that's based on the energy available to us now. You could imagine living, conscious systems which have a very different pace and therefore can extend out at least a lot farther than you'd imagine otherwise. You could have a living system where if it had a thought every 10 trillion years, that would seem normal. If our life dies out, one could imagine at some time arbitrarily, far in the future, a fluctuation occurs which allows intelligent life to exist again for a little while. So you might have islands in time of intelligence. As the expansion of the universe accelerates, it begins to spread matter apart faster than the speed of light. By this point, distant galaxies and stars are receding due fast that their light has become undetectable. The secrets of the cosmos are locked away forever. Current theories predict that atoms themselves will begin to decay, destroying all remaining matter in the universe. A proton, one of the fundamental building blocks of atomic matter, what makes us up, can just spontaneously fall apart. Any material that evades the pull of a black hole eventually dies away as its protons disintegrate. Proton decay is still unproven, and so this chapter of the future could look very different in light of new discoveries. The matter inside black dwarfs, the last matter in the universe, will eventually evaporate away and be carried off into the void as radiation, leaving absolutely nothing behind. With the last of the black dwarfs fading into oblivion, there won't be a single atom left in the universe. All that remains of our once vibrant cosmos are particles of light and black holes. And so begins the era of the black hole. No planets, no stars, no remnants of stellar debris to cling to. The universe, now a vast cold expanse, is at the dawn of a new age. Yet in the grand scheme of things, time has barely started to tick. For us, a human lifetime might seem long, but on the cosmic scale, the universe has just taken its first breath. The cosmos will spend most of its life in this state, cold, dark, and empty. It gives life only a fleeting moment to bloom, a brief respite amidst its fiery birth and icy demise. The arrow of time opens a radiant window during the universe's adolescence, a sliver of time when life can flourish. But this window is short-lived. If we measure the universe's lifespan from the Big Bang to the evaporation of the last black hole, the period when life, as we know it, can exist, is an infinitesimal fraction. A tiny blip in a timeline that spans eons. As black holes take over as the universe's fundamental building blocks, entire galaxies will be reduced to a supermassive black hole at their center, with smaller black holes orbiting around. These zombie galaxies, devoid of stars, will continue to evolve. Black holes will consume one another, merging and growing, some falling into the supermassive black holes at the heart of galaxies, making them even more massive. The universe will still be a place of intense activity, a dynamic and ever-changing landscape. But the timescales will stretch beyond our comprehension, trillions of years, not thousands or millions. In this distant future, change will still happen, just at a pace beyond anything we can fathom. Picture this, two black holes that have been together for eons, like cosmic dance partners. Now at the end of their long lives, they whirl around each other, closing the gap of thousands of kilometers in the blink of an eye. As they do, they send ripples through the very fabric of space-time, leaving behind a cosmic melody, gravitational waves. These waves stretch and squeeze space itself, spreading out from the colliding black holes like the echoes of a deep, resonant bell tolling across the universe. These are the sounds of space, quite literally, traveling at the speed of light as the two black holes merge into one, a single spinning, silent black hole. If you were close enough to witness this, your ears would vibrate with the rhythm of space stretching and compressing. You would actually hear this celestial symphony. Now imagine a smaller black hole spiraling into a much larger one. Each time the smaller black hole nears, it strikes space with a bang, creating a crescendo as it spirals faster and louder until finally it merges with its massive partner. Once thought to be eternal, even black holes will one day face their end. But this isn't a story of a few million or billion years. We're talking about time scales that stretch into quadrillions of years, a future so distant it defies imagination. In that distant epoch, even these mighty titans of the cosmos will slowly fade away, evaporating into the abyss of time. According to quantum mechanics, space is filled with virtual particles and antiparticles that are constantly materializing in pairs, separating, coming together again, and annihilating each other. In the presence of a black hole, one member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle appears to be radiation emitted by the black hole. And so black holes are not eternal. They evaporate away at an increasing rate until they vanish in a gigantic explosion. Quantum mechanics has allowed particles and radiation to escape from the ultimate prison, a black hole. Black holes begin to evaporate away, erasing the last large-scale structures in the universe. As they die, they light up the darkness one by one. As the black holes slowly die off, the universe continues to expand, driven by a mysterious force we don't yet understand. As black holes slowly fade into oblivion, the universe keeps stretching outwards, propelled by an enigmatic force we have yet to comprehend. This is the cutting edge of human knowledge, a vast frontier brimming with potential for exploration and revelation. Philosophers and poets once pondered, will the world end in fire or ice? Today, we can begin to answer that age-old question. Recent discoveries reveal that the universe isn't slowing down. Instead, it's accelerating at a breakneck pace. We now believe that in a future trillions of years away, the cosmos will meet its end in a freezing void. Even the emptiest patches of space are brimming with energy. Whether there's matter, particles, or radiation, each tiny cubic centimeter of space harbors this mysterious force. According to Einstein's theory, this energy exerts a gentle but relentless push on the universe. And what is this strange force that's driving the cosmos apart? We call it dark energy. This elusive substance makes up nearly 3/4 of the universe's total matter energy content, yet its nature remains a profound mystery. Unlike matter or radiation, dark energy doesn't dilute as the universe expands, which has profound implications for what lies ahead. So, what does the future hold for our universe? If dark energy continues to dominate and repulse, the cosmos will keep expanding indefinitely, faster and faster, spiraling into a runaway state. A staggering 70% of the universe's energy resides in empty space, and we have no idea why. But we do have a glimpse of what's to come. If this energy persists, the universe will drift into a cold, dark, and empty expanse. That's the fate that awaits us, as far as we can tell. Yet without truly grasping the essence of dark energy, we're left in the dark about our ultimate destiny and even our own beginnings. That's why delving into this enigma is so crucial. Unveiling the true nature of dark energy could transform our understanding of the future in unimaginable ways. If it diminishes over time, gravity could reclaim its dominance, leading to a catastrophic big crunch. But if dark energy gains strength, it might just rip the universe apart at its very seams. A cosmic big rip. Physicists are growing more confident that our universe might just be one of many, each with its own set of unique physical laws. Some of these universes could have the perfect ingredients for life, while others might be doomed to collapse or tear themselves apart. Still others could be stranger than anything we can even begin to fathom. There are missing pieces to this cosmic puzzle, just waiting to be discovered out there. While the current outlook suggests a universe that's destined to become colder and emptier, we can't help but wonder, could the end of everything we know actually be the start of something new? There are even theories suggesting that our universe's demise might somehow lead to the birth of another. Some scientists speculate that before entropy wipes out everything, there might be a way to escape. We could build simulated universes, or, if we harness enough energy, we might even be able to create a new one from scratch. The math and equations tell us that if we had a particle accelerator powerful enough to concentrate an enormous amount of energy into a single point, we could potentially open a gateway, a baby universe. When faced with the death of everything, this might just be our only ticket out. This leads to an incredibly fascinating, albeit speculative idea. What if every universe with intelligent life eventually creates its own lifeboat universes, baby universes that serve as an escape hatch? Could this be a way for life to ensure its survival, multiplying across countless child universes? It's a mind-bending possibility that leaves us wondering just how far our curiosity and ingenuity could take us in the grand cosmic scheme. Imagine a grand cosmic competition taking place in the vast expanse of the multiverse. A battle for survival among universes. The rules? Survival of the fittest, just like in nature. Universes devoid of intelligent life are infertile. They fade away without leaving any offspring. But those with the right conditions, moderate temperatures, stable stars like our sun, are fertile grounds for civilizations. These civilizations, with their advanced knowledge and technology, might even birth new universes, spreading their cosmic legacy. But if there's no escape, no way to transcend this universe, then the relentless march of entropy will continue unabated. One by one, even the mightiest supermassive black holes will succumb. As the final giant collapses, it will go out in a blaze of glory, flooding the universe with a final magnificent burst of light. And then, silence. After eons beyond imagination, the universe will be an empty void, a cold sea of photons drifting aimlessly. As they lose their energy, cooling towards absolute zero, the last whispers of what was once a vibrant cosmos will fade. When the last remnants of the last stars decay into nothingness and everything reaches a uniform, freezing temperature, the universe's story will draw to a quiet, inevitable close. Time becomes meaningless,